So this is the project right here, the Shopping for Stuff project. And there are a few branches on here. Eventually we will see a Stripe branch when I push that live. But if you do want to code along, you have to either go back to the master branch if you were working in a separate branch before, or reclone this repo. I'll just quickly put the URL to the repo in the chat here. Where's my chatty chat? There it is. And so if you do reclone that repo, remember that you'll have to do like a bundle install and a yarn install and a Rails DB migrate and a Rails DB seed. So there's a few things that you got to do, or you could just watch today, right? You don't have to necessarily code along. You could just give yourself the permission to watch. Depends on how you like to do it. So yeah, that's where we're going. So when we reverted back to just the master branch, the cart button and cart functionality is gone. What I'm going to be adding today is a buy now button, an individual buy now button for each product. So I'm not going to show you how to integrate both the cart and the buy now. We're just going to keep things simple and focus only on the buy now. And then I'll talk a little bit about what would be required to sort of expand what we've done in today's class to actually deal with the shopping cart as well. Okay, so this is our starting point. And then I'm going to pull up VS Code here. So here's VS Code. I've got the Rails server running in one of my terminals. I've got the Webpack dev server running only because well, I was having some weird issues. It's almost like once you run this Webpack dev server once, then the Rails server stops being responsible for serving up your JavaScript assets. So I was getting these issues where my JavaScript wasn't getting properly served up, and we're going to rely on JavaScript today as part of the checkout process. So I had to run both the Rails server and the Webpack dev server, and then I'm going to open up a third terminal just for typing stuff into. So that's yeah, that's where we're going to go. It's all going to begin with the with Stripe. So we're using Stripe for our credit card processing. I'll pull up the Stripe website here. Again, if you want to code along, you'll actually need a Stripe account. And so I'm going to go log into my Stripe account here. Look at all the money I'm making on Stripe, everybody. Dollar bills, $4,000 yesterday alone. Can you believe it? All in virtual money that is not real. This Stripe is now sort of running as test data in a sandbox, which gives you the ability to play around with Stripe without having to use real credit card data and all that kind of stuff. So if you get yourself a Stripe account, there's just one setting that you have to make sure that you set up. You don't have to provide Stripe with any credit card details. You don't have to provide Stripe with any banking details. What you do need to do is in your settings, which is over on the left-hand side here, you have to make sure in settings and then further in account details that you have specified a public business name. My public business name is just my name. There it is. It's Kyle. You just need something in there for your public business name. Otherwise, when you try to hit the API, you will get a 500 error, and that you don't want that. The other part of the process that we'll be looking at a little bit later is this idea of API keys. So Stripe, like a lot of APIs out there, uses public-private key encryption to authenticate your server. And so there is a publishable key and a secret key, and we're going to be bringing those into our application by way of environment variables. So that's another part of the process that we'll need to get from Stripe. And then if I just go back to stripe.com, the reason I use Stripe for this, there are other options. The biggest player in the space that might come to mind when thinking about payment processing online would be PayPal. I tend to use Stripe mainly because they are very developer focused. And because of that, their developer documentation is just really, really good. And I'm sure PayPal's documentation has improved, but when I first started doing payment processing online and using the PayPal API, it was a little bit painful. I mean, I got it working in the end, but yeah, the developer docs at Stripe are just, I would say they're incredible. I'll just load it up. They have libraries for, all these languages listed: Ruby, Python, PHP, Java, Node, Go, and .NET. And in the developer docs, they give you code snippets for any one of those libraries. So it's just really nice and easy to, for example, if I go to authentication here, this is the code snippet for if you're using Python, but I could just switch it over to, oh, I'm using, Ruby. It gives me Ruby code. Oh, I'm actually working in like .NET today, and it'll give me a snippet of .NET code. So it's just a very, very well documented API for any of the endpoints that are available. It shows you what those endpoints are, what HTTP verbs you use with the endpoints, what the JSON responses look like. It's just a really well documented system, and this was their strategy. I actually heard the one of the creators of Stripe interviewed. It's now like $1 billion company, and their initial strategy was to be as developer friendly as possible, knowing that developers are often in a time crunch, and the better the docs, the more likely a developer will adopt your product compared to another one. And so, yeah, it seems to have worked out for them, being that they are now a $1 billion company. So they're making lots of money, and they make money through micropayments. So for every payment that goes through the Stripe API, they're taking approximately 3% of that sale, which if you think about all of the e-commerce payments that are going on right now online, 3% of all of that is a lot of money. So that's my little pitch for Stripe. I mean, it's served me well, and that's all I will say about that. There are other alternatives, and I occasionally for clients will integrate PayPal as well, just because some people want that PayPal button on their sites as well. Okay, let's see what we do to get Stripe into our application. The first thing that we need to do is let me just make sure I'm in a branch. I think I made one before class. Yes, I'm in a branch, and I branched off of master. Okay. I'm going to go to my gem file, and I'm going to add the Stripe gem. And so just gem Stripe, and then I'll do a bundle install. Stripe used to have a legacy process that was built specifically just for Rails. Like they had like a way of integrating Stripe really easily into Rails applications, and they've since deprecated that. They still have support for Ruby, but just not Rails specific support. And so it's a little bit more complicated than it was in the past, but it's still not that bad. And just as like a side note, like the entire Stripe system, like sort of the Stripe backend itself, is a Ruby application. So it's not a Rails application, but all of Stripe itself is built on Ruby. And it's such a large application that the one pain point that they were feeling by using the Ruby language was they were missing types. And so they actually made their own type system called Sorbet that can be added on to Ruby. So they built a type checker, which you can use to add type annotations to Ruby programs. And they are actually in talks with the Ruby language designers to see if they can get something similar, or even Sorbet itself, into Ruby. So it's a neat idea. A lot of sort of dynamic languages are moving in that typed direction. So you see things like TypeScript, which is a typed version of JavaScript. PHP has type annotations now, and yeah, so Ruby, they may be coming to Ruby. Potentially even this Christmas. Ruby 3.0 is dropping on Christmas Day, next month. So I'm not quite sure what's going to be part of Ruby 3.0, but we will see. Okay. Bundle install, that's one thing we have to do. Another thing that we have to do is that there's a JavaScript component to what we're going to be doing, and we're going to add that inside of our application html.erb in our view layouts folder. And so I have a reference app here that I'm just going to reference. And so inside of the head tag here, I'm going to put a script tag, and within that script I'm going to set up a source, and I'm going to say https://js.stripe.com/version3. And that, just to make sure that that actually works, I'll control click that link and just let that load up inside of my browser. And that's what I want to see, a whole bunch of minified JavaScript. So that's the right place. So with this in place, we will have access to a capital S Stripe object inside of JavaScript. And then with the Stripe gem in place, we're going to have access to a capital S Stripe class within our Ruby code. So we're just going to get access to the Stripe API in both the client side work that we're going to be doing and the server side work that we're going to be doing. So those are our initial steps. I can do a little bit of a git add and a git commit here. Added the Stripe gem and the JavaScript associated JS. I need to configure Stripe a little bit when the Rails server boots up, and in the config folder for a Rails project is this initializers folder, and I've shown you this folder once before this term. It already contains a bunch of files, and any file you put in this folder will be run at boot time. So when you run Rails S, all the initializers are executed. So I'm going to put a new file in here, and I'm going to call it stripe.rb. And inside of here, this is where I'm going to configure the Stripe gem with my publishable key and my secret key. And I'm going to set that up as Rails configuration data. So the capital R Rails class has a configuration property that I can attach configuration data to. So I can say, put some configuration data for Stripe. So that there was no Stripe property before. I'm adding one right now, and I'm just going to make it a hash with two keys, a publishable key, and we're going to see that this is going to go to env publishable key. And what the capital env hash is it's what allows us to access our operating system's environment variables. The reason why we want these keys to be inside of environment variables is that we don't want to include the secret key specifically in our source code. Because if we push this to a Git repository, a public one, then that secret key would be in a public repository, and that would be a bad scene, because that's how the Stripe API uniquely identifies you and verifies that it's your account that they are in communication with. And so you got to keep that secret key secret. And so those are going to be environment variables. If you go through the deployment step with either Heroku or Docker, you're going to have to set those up as environment variables in those environments as well. In Heroku, there's a way of doing that with the Heroku command line tool and also just the Heroku web dashboard. And I'm pretty sure I go over environment variables in the Docker video as well. And then I got to go to the Stripe gem itself and set its API key. And I'm going to just retrieve it right back from where I stashed it. So I'm going to say rails.configuration.stripe, and I'm going to give it the secret key. And I need to now restart my server with those environment variables in place. So I'm going to Control C on my server. I'm going to go over to my Stripe dashboard, and I'm going to copy my publishable key. And the way you set up environment variables differs depending on the operating system that you're working in. The easiest way to provision a Linux tool with an environment variable is to execute that Linux tool with the environment variables defined on the same line as the command. So I could say publish, here I'll make this go a little bit higher on the screen, publishable key equals, and I can paste in that publishable key and then a space, and then I can say secret key equals, and then I'm going to show you all my secret key here. So that means you could actually impersonate me now on Stripe. Oh, and I need a password. Okay, well, why don't you fill that out, please? There it is. That's the key to my riches, folks. $4,000 in fake money could be yours. And so notice here, I'm defining both of the environment variables and then a space, and then I'm just executing Rails S so that this Rails server will now have access to these two environment variables. So I can just run that server again. And when it loads up, this Stripe initializer will load up. It'll pull those keys from the environment hash, pulling them from the actual environment, and then it'll set that up with the Rails config. Yeah, exactly. So it's not persisted. You would have to do that every single time you ran Rails S. Or you could set that up in something like a bash RC so that it just always creates those. Again, like how you set that up, it's going to differ, but depending on how, if you really want those to stick around forever. I always just pass them in like that. But yeah, it won't persist. Yeah. Yeah. And there's actually one that's just called .env. And I think there's like a version of the .env library for like all different programming languages. Because I think there's a .m for Python, and I know there's a .env for Ruby, and there's one for JavaScript. So yeah, you can definitely check out that gem. And then you just put in like a hidden file in your folder that's like .env. And then the key with that though is you have to make sure that in your git ignore that you add the .env to your git ignore, so that file doesn't get committed to your repo. Another thing you can do instead of using environment variables is Rails has a thing called encrypted secrets, and it's a way of persisting secrets into a repo, even into a repo that goes up public, in a way that is encrypted. But the key is you still need some decryption key, and so that decryption key that would decrypt your secrets would still have to itself be an environment variable. So at the end of the day, you need something that's hiding these things. And so yeah, a .env file would work. And again, though, for deployment, you'd have to make sure that you got that .env file to your deployed application, because it's not going to be in your Git repository. So you'd need that .env file to be put into your deployment environment as well. Okie doke. That's running. Good. What do I need to do next? Next up, I need to set up a new controller and some new routes. So I can close this gem file, I can close the application and the Stripe here. I can go to my terminal here, and I want a new controller, and it's going to be a checkout controller. So I'm going to say Rails generate a controller called checkout. Let that execute. That'll get me my checkout controller, and I can control click that to open it up. And in this checkout controller, I'm going to want a create action, not that thing. I want a create action, and this is going to establish a connection with Stripe and then redirect the user to the payment screen. That's one of the actions that needs to exist here. And then Stripe also assumes that you have two endpoints on your machine, one for success. We took the customer's money. And one called cancel if things went wrong. Something went wrong with the payment. And this will be like a sad face. All right, there we go. So those are 3 different actions that we will eventually code out in our checkout controller. And we need routes for those actions. So I'm going to go into my config, close that up, into my config routes file. The routes here are not really going to conform to the standard Rails RESTful routes. So we're not going to use a resource command to get access to these routes. I mean, one sort of looks a little bit like, you know, one of the RESTful routes, which is the create, but success and cancel don't follow that standard pattern. And so what I'm going to do for these routes is I'm going to define what are called scoped routes, something I haven't shown before. It's just a way of creating a number of routes that all start with the same sort of subcomponent. So all of our routes are going to start with /checkout/. So I just say scope checkout do, and then inside of there I can define my routes. The create route is going to be triggered with a post request because we're going to post it some data from a form. So a post to /checkout/create is going to go to the checkout controller's create action, and I want to call this route checkout create. And then the other two, there's going to be the success one. It's going to go to checkout success as checkout success. Double the C and double the S, and you will always have success. Checkout cancel. Checkout cancel. Make sure I didn't typo anything there. We got create, we got success, we got cancel. They are spelled the same in all 3 places. Yes. Okay. Those are the routes that we have in place. If you ever want to quickly check your routes just from the command line, you can do so. You can just say Rails routes. And it'll give you the same feedback that you get normally when you're looking at routes inside of the browser. But here are the routes that were just defined. It's a bit too wide, you know, so it sort of scrolls off the edge, but you can see we have create, checkout success, and checkout cancel. They seem to be going to the correct locations, and they seem to be triggering the correct actions. So that looks nice. That looks nice. I can do a git add and a git commit -m, a new checkout controller with associated routes. Routes. Okay. Yeah. Now we need that form I was talking about to post some data to this create action. So I'm just going to put a little comment here. A post to /checkout/create is going to trigger this action, and the expectation is that a product ID will be in the params hash at params product ID, like that. And so we want a form that can send us the product ID that the customer wishes to purchase. And the way we're building this now is just little buy now buttons, one for each product. And so if you remember how I developed this application, I did so with a partial for the products. So that's where I'm going to want to put that nice little form. And it's going to look really similar to the form that we used. I'm going to go to my views, products, product partial. It's going to look really similar to the form that we used for our shopping cart. So I'm going inside the aside below the product description, and I'm going to say form with, the URL is the checkout create path. And so we'll say checkout create path. I think I need to explicitly tell it remote true. We could try it with or without that. Remote true, I'm not sure if it's required, but what it's supposed to do is it's supposed to force this form to make the request with an AJAX request using an XHR rather than do a standard form post that goes to a new page. I think that's now the default behavior of form with, which is why I'm wondering if I actually need this or not, but it doesn't hurt to have that in place, especially because it sort of serves as a little bit of documentation for, you know, your future self or another developer, so that, you know, yes, this is a form with, but is being sent via AJAX. It's going to be not going to trigger a full refresh of the page. And then within that form with, I need a hidden field tag. This is where I'm defining the product ID. So this is when this gets submitted, it's going to go into the params hash at position product ID, which is what I said I wanted here. And then the value of this hidden field is going to be the current product's ID. And then last but not least, a button tag that just says buy now. Maybe with a picture of a credit card. There's a credit card. Buy now. Buy this thing. Buy it right now, please. And if we go over here and we reload, look at that. Some beautiful buy now buttons. Now, there was one thing that tripped me up like crazy yesterday, which was, you know, if we go and view source here, we can see that for each of these forms, they look good. They're going to the /checkout create action. They've got their data remote true. That's not a regular HTML attribute. That's what tells Rails's JavaScript to make this thing submit with an XHR request. They've got their hidden authenticity token to protect from attacks. And then they've got this hidden input. And you can see the value is the primary key of each one of these things. So value 1, value 2, value 3, and then a button. A really weird thing, though, was happening yesterday with my application, and it was only happening in Firefox. And I would click this button, and it would work. And then I would click, another one, and it totally wouldn't work. And I would view source, and it would look like all the IDs were correct. But if I went into the inspect little widget and I looked at the value of some of those hidden inputs, after submitting one, some of the values started changing. And they started becoming these really long, weird, strings of letters and characters. And after thinking I was going crazy for a while and banging my head against the computer, I found a GitHub issue somewhere on a completely unrelated project that talked about how Firefox sometimes accidentally auto completes hidden inputs. And so I had to disable that by saying autocomplete off. And the only reason I knew it was Firefox specific is that, because it was just so weird that it wasn't working for me. So I started trying out the functionality in like Chrome and in Edge, and it worked in Chrome and it worked in Edge, and it still didn't work in Firefox. And then I found this idea that Firefox was erroneously triggering autocomplete on hidden fields. And so that autocomplete off fixed the problem. That was, yeah, that one took a while. That one took a while to figure out. I had like 42,000 tabs open, I think, by the end of that journey. So that's one of those things. So now that I know the answer, I can just put that in there. I don't know if that's a bug that's going to be fixed in future versions of Firefox or whatnot. I don't care now that I know how to solve it. Okay, and that's that. So I can reload this, and everything is good. We can test just to see if this is, again, sort of doing the right thing. I can go into my network tab of my dev tools. I can delete all of the requests, and I can click it once here. And notice it doesn't change the page, right? It's being done by way of an XHR request. We could even, verify that by going over here and saying filter the network tab and only show XHR requests, only show AJAX requests. And you can see they still show up. You can see the initiator is at XHR. And if we click on any one of them and we go to the request, we can see that the data that's being sent is the authenticity token and the product ID. And the product ID is the correct product ID for each one of them. And that's where my debugging journey eventually led me. I went in and I looked, and the product ID was this big, long, crazy thing. Okay, so that is working. That's good. That means that we are getting to here. Nothing's actually happening yet, but we're getting there. And so next up, we need to implement, in pieces at least, this stuff right here. We need to, it says here, establish a connection with Stripe and then redirect the user. We also need to load up the product the user wishes to purchase from the product model. So that's going to be the first thing. Then we're going to establish a connection to Stripe, and then we're going to redirect the user to the payment screen. So step one is loading up that product object. And so I'm going to say at product equals, go to our standard product.find and pass in the params at position product ID, because that's what we're getting from our hidden input. That's the product ID right there. And just because we're dealing with an endpoint that deals with money, this could be a potential endpoint that bad actors might try to mess around with. They might try to send weird data to this endpoint. And so I don't even want to engage with Stripe if someone's trying to like fuzz this endpoint. Sometimes people will try to fuzz endpoints by just sending them sort of random data. And so I'm going to say here, if we didn't find any product, if we didn't find, like if someone has sent me a product ID that doesn't even exist in my database, well, then don't even continue. Just redirect to the root path and then just completely escape out of this, this action. Don't bother continuing on to establish the connection with Stripe, because you would be establishing a connection based on bad data at that point. Oakley dokley. Gonna skip the actual establishment of the connection with Stripe just for a moment and work on how this redirect is going to work. We're gonna see something, a new thing, something I haven't shown you about Rails. You all know that normally at the end of any action, Rails will load up the associated view. So the actual flow now would be, if I just left the code as is that when we got to the end here, Rails would go look in the checkout view folder for a create.html.erb. So that's normally what gets sent along. We send back to the user some HTML. But there's a really neat feature in Rails where you can actually send back some JavaScript. You can send back a JavaScript payload, which then the browser will then execute. And this is actually how I used to do dynamic reactive stuff in Rails before React existed, because you could, have the user trigger something, you could send them back some JavaScript, and you could use the DOM to, manipulate portions of the screen. And there's even JavaScript helpers that Rails gives you that allows you to render Rails partials from your JavaScript. So you could say, like, change the cart partial when the user submits something, and you could target that portion of the screen and just change it. It was a really neat way of doing React-like stuff long before React came on the scene. And so we're gonna use that little bit of Rails functionality, and you get that ability by putting in a respond to block. And if you've looked at a scaffolded controller, you'll see that the responds to is in all scaffolded controllers, and in the scaffolded controllers, it's how Rails determines whether or not it's going to send back HTML or a JSON response. In our case, we're going to just say, if the format is JavaScript, then do your default thing, which is to render in the app views checkout folder a create.js.erb. And look at that weirdo extension, js.erb, meaning that what's going to be sent to the browser is JavaScript, but we can actually embed Ruby inside of this file and have that work like ERB inside of HTML. So we can put embedded Ruby in our JavaScript, have that execute on the server before the JavaScript is sent out, and then that payload will be sent to the browser. So the Ruby's not being executed by the browser, it's being executed on the server, and we're going to use it to inject some data into our JavaScript. And if we had other things, so you could also put like a format HTML here, and then based on how the request comes in, it could do one or the other, but we only really care about format.json. And Rails will know that it's format.json when it gets an XHR request, and we are doing an XHR request because we're remote true. And we would even see that if we go into our server here. When I was trying out that button, it says here, started on a post to checkout create, and then it says processing checkout create control, or checkout controllers create action. And then the key thing is here is this is the format as JS. Whereas if you go to other requests, maybe I got to go way up to the top here. It'll say something like as, well, maybe I'll just go trigger one. If I go to the, the show page, and we go look at that show page here, as HTML. And so Rails always sort of knows what mode it's in, what format it's in. And so when we do an XHR request, it's going to be an as.js, and it's going to respond with JavaScript rather than HTML. And we need to make that file exist now. So I'm going to go into my view checkout folder, and it's currently empty. I'm going to make a few files in here. I'm going to make 3, in fact. I'm going to make a create.js.erb. I'm going to make a success.html.erb, and I'm going to make a cancel.html.erb. And so the other two are for our other two actions. And so inside of like success, we could say, yay, we took your money. And then we could put that emoji of the money and the wings flying away. There we are. And then in the cancel one, you know, the least helpful of all error messages, something went wrong. So we're not going to go into any details there, but you know, we could talk about how we could actually give more helpful messages. But for now, we'll just have some placeholder text there for cancel, and success, we just have some placeholder text there. Now for the create, up here, I have made us a product variable, and it's an instance variable. It's got an @ sign at the front of it. And so that'll be available to us inside of our view. And so just for testing purposes and to sort of show off this idea of Ruby embedded inside of JavaScript, I'm going to put console.log, and then inside of quotes, I'm going to put in an ERB, and I'm going to go and output the product name. So when the checkout controller triggers, we'll receive a product ID in our params hash. We'll find the product. We'll make sure that it isn't nil. And then we'll go and start rendering this create.js.erb, at which point we will inject the product name into this string, and then we'll send all of this as a payload for the browser to execute. The one thing that'll look a little bit weird in this file is that we haven't told VS Code what a js.erb file is. So it's not going to do proper JavaScript syntax highlighting in this file. And we could configure VS Code to do that, but you know, we're only in here for a short amount of time, so we're not gonna bother with that right now. Let's just see if this works. What this means is if I go back to my home page and I pull up my console here, let's see if this works on the first time or not. What I'm hoping is if I click buy now, it should say heavy duty wooden keyboard. And lo and behold, it says heavy duty wooden keyboard in my console. And if I click here, I want it to say lightweight marble shirt. And it does. And if I scroll down a little bit and I pick like this sleek rubber shirt, oops, I clicked the wrong button, but nonetheless, buy now. And there it is. Boopity boo. What is it? Failed to execute post message. I'm not sure what that's all about. Go back. I'll go back home here. Okay, so that again, debugging wise, that is working. We can see all of the product names below. That's not exactly what we want, but that just was to sort of show off that we have this ability to do ERB inside of JavaScript. We can now actually delete that. That was just for testing. The other thing I'm going to do now is because we actually don't need access to this product variable outside of this action. I only wanted it to be an instance variable so I could do that little demo inside of the JavaScript view. So I'm going to remove the @ sign on line 7 and also on line 9. Like that. And now we can get to this idea of establishing the connection with Stripe. So this idea of redirecting the user to the payment screen via a JavaScript view, we still need to implement that, but we need to implement it inside of our create.js.erb. But first, we're going to look at this establishing the connection. When you establish a connection with Stripe, they call it a session. And so this is a different kind of session than, you know, your Rails session. This is more like a session on their end, on the Stripe API side of thing. And so we're going to create a session variable. I'm going to make it an instance variable because I am going to actually use some of this session data with my JavaScript view. And then I'm going to go to the Stripe gem that we set up way back when. And I'm going to say Stripe checkout session create. I gotta put an E on the end of create though. There we go. And then in the create action, there are, things that I need to set up. So at this point, when I was first figuring out how to do this myself, I went to the Stripe API and I looked up Stripe sessions and I saw what the create action was all about. I've already done all that research, so we can skip that part of it for now, and you can just trust me that this is what needs to go in here. Payment method types. We're only going to accept credit card. Stripe wants both a success URL and a cancel URL. It wants endpoints back on your server that it can redirect that user back to. And we made those endpoints, right? We made them in our routing file. We have a checkout success and a checkout cancel endpoint. We made views for them. We made actions for them that are currently empty. And so here I'm going to say checkout success. Normally we use dot or underscore path, but we do that when we're sort of within our own system because underscore path will give us the relative path without including the rest of like the URL. So it doesn't include the HTTP or the local host or any of that. What we actually want here is the checkout success URL, and that'll be everything. http:// domain name / path. And then I need a comma after that. And I also need the checkout cancel URL. Why are you squigglied? Well, you probably just want to align them in a pretty way. Okay, that's good. And then last but not least, Stripe wants to know what the user wants to purchase. What are we charging someone with? And so what we're doing here is we're setting up a session and we're saying, Stripe, I have a customer that wants to buy the following line items. Please prepare a session for that. Then we redirect the user over here to a payment screen, and then Stripe's going to already have established that this customer wants to buy these specific line items. It's going to know what session that it relates to, because we're going to use this session variable inside of our create action to tell Stripe that this is, the session that we've already previously established. And so here we're going to pass an array of things that the customer wants to buy. And in our case, it's just one thing. When you implement this with your shopping cart, this will be actually an array of things. So when it's just one thing, I put in a hash inside of this array. And inside of that hash, I say name, and that's our current product name. That's this product that we've loaded up here. And a description, which is the product description, and an amount. How much does this thing cost? And Stripe is expecting a whole number of cents, right? So $5.55 will be sent as 555. And so I have stored my price in cents, so I can just send that. If you've stored your price in like a decimal value, then you would have to multiply that by 100 and cast it to an integer. But I can just get away with just doing that. What currency do we want to charge the user with? This could be dynamic. We could, depending on where this customer lives, we could change this, but I'm just going to hard code it to Canadian dollars. How many of this particular item is the current customer wanting to purchase? Well, I'm also going to hard code this, but if you are implementing a shopping cart with quantities, this is where you would put your quantities. And that's it. And so again, if you have a shopping cart, what you're likely going to want to do here is probably above this, you're going to want to loop over your shopping cart and produce an array of line items, each one of those line items having a name, description, amount, currency, and quantity, and those will be pulled from your shopping cart items. So I have a single thing in here. You would probably ahead of time loop or map over your shopping cart to produce your line items array with multiple line items in them rather than just the one that I have here. Let me look at this. This looks good so far. Okay, that's going to set up. So this call here, this actually is going to have our server connect to Stripe. That's why we've given the Stripe gem access to our private key. So this actually connects to Stripe, sets up the session behind the scenes, and then this variable that's returned to us is full of all sorts of information about the session that was just set up. And one of the bits of information is Stripe's internal ID for that session. And so when we then redirect the user to Stripe, we have to provide the Stripe ID for the session to relate one to the other. And so that's the final step that needs to happen over here. And so inside of I'm back in my JavaScript file, I'm going to say const Stripe. I'm going to set up a little variable here, and I'm going to go to my Stripe object, and I have access to this object. This is why we added that JavaScript tag at the back at the beginning of the lecture. If you can remember, about an hour ago, we put that in there. And what do I need to do here? Well, inside here, I'm going to publish my publishable key. So Rails configuration Stripe publishable key. And so this key is going to get published with the JavaScript payload that's being sent to my end user browser. And that's fine because this is the public key. It's publishable. It's okay for us to send the public key. We don't send the private key. That has been used internally to communicate with Stripe to set up the session. We just need to send the publishable key to the end user's browser. And what else do we want to do here? I got to use that Stripe that was just set up, and I'm going to say redirect to checkout. And I'm going to provide an object here. And there's only one thing that goes into this object, which is the session ID. And it's a string, and it's going to come from ERB. That's why we needed some ERB. We needed ERB to get the publishable key in here. And then we needed ERB to get the session ID in here. So we're going to go to that @session variable and just go to its .id, and that will be Stripe's internal identifier for the session that we've set up on Stripe. And so what I mean by that is if we go to Stripe here, each one of these things was originally a session. And this is the identifier for that session right here. And then eventually it's listed as succeeded. If anything goes wrong in this process, if we set up a session and then the user either abandons ship or something crashes in the redirect to set up the JavaScript, we would see that in here as well. We would see an incomplete payment. And incomplete payments show up in this list for a while, and then I think they're just garbage collected and removed after like 24 hours or 48 hours. This redirected checkout returns to us a promise. And so it's an asynchronous thing. It returns to us a promise, and this promise is only going to be fulfilled, I think, if something goes wrong. If memory serves me correctly, this promise is for error handling purposes. And so you could have a function here which would, fetch a result from the returned promise. And then inside of here, normally you would do something nice here to alert the user as to what went wrong. Again, I'm not going to code out a full user-friendly implementation here. So just for debugging purposes, I'm going to console.log result.error.message. And that will give us at least something to go off of. If something does go wrong, we can look into our console and see if we are getting an error back from Stripe. Okay, that looks pretty good. We set up a Stripe variable, we pass the publishable key, we ask the Stripe object to redirect to the checkout, and we give the session ID with that. And then we have a promise to deal with any problems that occur. Let's try this out. There might be some debugging that we have to do, but we'll see. And so I will reload this page. I'm gonna buy, what am I gonna buy? Oh, look at that juicy orange. I'm gonna buy this intelligent iron keyboard disguised as an orange. And so clickety clack, I'm gonna click this buy now button. Let's see if this works or if we have some debugging to do. So buy now. Ooh, look at that. Look at that. Intelligent iron keyboard, $761.87. There was the lorem ipsum description right there. I now have the ability to pay for this. And so here's my email address. I'm just gonna show you all my credit card. Please don't use it to purchase anything after class today. That would be very wrong of you. I put my expiry date in here and my secret back of the card code. This is Kyle Geske card here. And now we're gonna fire this off to Stripe. Little check mark. It redirects me back to my checkout success page. Look at that. Yay, we took your money. That's also cool. And if we go back over here and I reload my payments here, let's go back to payments. Look at this new payment that just came in from a certain Kyle Geske, $761.87 specifically. If we go in here, we see, you know, the last 4 digits of my Visa card. A risk evaluation. How risky is this Kyle Geske? Well, he's a 9. And it gives us all other kinds of details. It even geolocates me. It knows exactly that I'm in Winnipeg and that you know, there's my computer. Risk insight. Yeah, it gives you all sorts of information, right? So that's related payments. These are probably related. They're all using the same IP, et cetera, et cetera. So, I mean, that's nifty. The payment went through. We could sort of show the two sides of things. What I mean by that is showing that first the session gets set up and then we sort of fulfill the session. So if I go back to here and I load up this practical steel bag, clickety clack. If I pause here and before putting in my credit card details, I go back to Stripe and I reload this payment screen. Is it going to show me the session? Oh, is that what it is? Aha, thank you very much. There is the incomplete for the $756. That is the amount here. And so, you know, often customers will get to the last step in the process and then they will abandon ship, right? And so you could always go and look into your Stripe API and sort of see like how many customers are sort of abandoning the process. You would sort of know if they got to that final stage, and then they could also indicate that there's a bug in your code, right? If everyone's getting to an incomplete state and you have no successes, that means that something is going horribly wrong in the process. So these incompletes get sort of garbage collected after a while, I think. There's a few from the, no, I guess they don't, because look, that's one from like April 2020. So that's April earlier this year, and this is from 2019. So I guess those just stick around. Regardless, the successful ones, they'll be converted to successful. So if I went through that process again and I put in, you know, an email address, we use the 4242 is not really my credit card. It's just the Stripe credit card that always works in their test in their test environment, of course. With it, you just always have to put in a expiration date in the future. So if you put in an expiration date in the past, it won't let you through. The CVC, you can just put any 3 digits for that. Name on card can be anything, and I don't even know if the postal code needs to be valid, but I just do all R's and 3's, and that seems to work. And then I click through here, and then again, we took your money. And if we went back to the payments page here and reloaded it, or went to the all here, we would see that that is now a successful payment. It's gone through. This customer here bought it. Customer Keymash. And yeah, I mean that's sort of the long and the short of it. There's not really that much. Oh, I wasn't watching the chat. Sorry. Were there any like crucial questions in the chat here that I totally ignored? Yeah, that is a great question. And we will get to that. I'm just scrolling through here. Okay, no, it looks like we're all good. Okay. Yeah, taxes. There's a few different ways of dealing with taxes. The easiest one I found was just to add other line items. And so here's a line item called GST. And the description is goods and services tax, and the amount is the product price cents times I think I have to, no, this will be fine, it'll floating point it. What are we at, like a 5% GST? Is that what it is? I guess it doesn't really matter. And then convert that back to an integer to I, and then the currency is Canadian, and the quantity is 1. Oh, I need a comma here. So for your project, again, if you have customers that have provinces, you would need to check to see which taxes apply. And so again, you probably wouldn't do this in line. You would probably first loop through your line items, creating one line item per item in your shopping cart. Then you would loop through the taxes that your user has based on their province. And for any non-zero tax, you would add a line item for that tax into the system. And so now if we go back to the application here, and I try to purchase a mediocre wool chair, we can now see the mediocre wool chair and the GST. And you know, if there had also been a PST, that would just be another line item. I think there are better ways. There might even be ways of establishing taxes that work directly with the Stripe API. This is just the one thing that stood out to me as an easy way of getting taxes into Stripe. And then again, we'd go through this payment process, we'd pay that, and now we're paying a total. The amount here is the sum total of all of the line items. And so that's why it's 246, because it's taken the price of the chair and it's added the tax to it for us. So you don't have to do the grand totaling yourself. You've probably, though, in your checkout flow, you've probably already done that yourself. And so Juan says, so this is, oh, that's neat. So you can actually add it into the line items .data.taxes. So it looks like there is like a more proper way of doing it. So it's up to you whichever way you wish to do. If you want to dig into the Stripe docs and find like the official Stripe manner of doing it, or if you just want to add it as a line item, either one will work for me. The other thing that I want to talk about now is, we've sent the user off to Stripe, and they've sent back, they've been sent back on success to this page here. But how does my application know that the payment went through? Right? Stripe knows that the payment went through, but all my server knows is that we requested a certain amount of money and then sent the user off. And that's it. From the view of my application, I guess I could know that they came back to this this route, but I don't really know if they made the full payment. And so that's the tiniest little thing that we need to add in now. The problem is that we can't add it in the full proper way. So the full proper way of dealing with this is in your developers section on Stripe is a section called webhooks. And you can add what are called endpoints, webhook endpoints in here. And what those webhooks do is when Stripe receives a valid payment, they will actually hit a URL on your server. So you can set up some routes on your Rails application that are not for humans to hit, but are for Stripe to hit. This is like the official proper way of dealing with processed payments in Stripe. The reason we can't do this, at least in development mode, is that if Stripe wanted to hit a webhook, well, they'd be trying to hit you at your local host. They don't have access to your local host. That's just internal to you on localhost. I looked into this a little bit. There are a few solutions. One of them is this nifty tool called ngrok. It's a cool thing. It allows you to make tunnels, basically that give you a public-facing URL that will actually tunnel through to your local host. So you could use ngrok and set up a webhook for one of the ngrok public-facing URLs that ngrok gives you, and then you run the ngrok program on your machine, and those requests tunnel in. That's one way of doing it. It turns out Stripe also has its own version of ngrok with their Stripe CLI. So they've got a Stripe command line tool, and when you run it, it will establish this tunnel in development mode. So they know that this is a problem, and so they give you this tool to set that up. And if you look in the webhook section, you could say devices receiving events from the Stripe CLI. So they even sort of track that here, and this is how you download the CLI. And so you could go the webhooks route. And if you were actually developing a real e-commerce store, I would implore you to use the proper webhooks route. It's the only real way you would want to actually deal with confirming payment processing. I'm going to show you a sketchy way of dealing with the payment processing that you should only use for this project. It's a very brittle, sketchy way to deal with the confirmation, but it's enough so that you can sort of like close the loop. You can feel like you've sort of done all of the things, and you can get a response from Stripe, and then you could maybe even mark the order as paid in your database. But it's definitely something you would never want to do in a production application. I repeat, do not do this in a production application. So if you were building this out for your project, one of the things you probably would do up here at the create step is you would create an order in your database, likely marked as unpaid, and associated with that order would probably be a number of line items, one for each of the items that you were sending off to Stripe. And then on success, you probably want to stamp that order as being paid, and maybe even save the order ID, the Stripe order ID, so that you can have an association between Stripe and the payment that actually went through and your database on the local side. So I'm going to show you how you could do that, but again, not a real world thing. You would not do this in the real world, and we'll talk about why this is so sketchy after we do it. So When looking for a way to handle this, what I found was that there is a little feature of the Stripe success URL here that you can sort of mess with. That if at the end of the success URL you append a string that says question mark session ID equals, and then in curly braces checkout session ID. If you put that at the end of your success URL, when Stripe redirects you back to your, or redirects the customer back to your server, at the end of the URL, it's going to put a question mark session ID equals, and it's going to put the ID, the actual Stripe identifier for the session, in there. So it's going to sort of interpolate that in to the URL. And that's going to come to your Rails application as a get parameter. Because you remember on the web, anything following a question mark in a URL that is like a key and a value ends up as a get parameter. And for Rails, those end up in our params hash. What that means is with this in place, inside of the success action over here, we can load up our session. We can get access back to the session that we established here, and we can check if the payment went through. And so the way that's going to work is over here in success, we're going to say session equals, and we're going to go to the Stripe gem, checkout session, and we're going to retrieve, and then we're going to use the session ID here. And from that session that we retrieve, we can pull in what Stripe calls a payment intent. And this is where we can look up if the payment went through, how much was actually paid, etc., etc. So Stripe payment intent dot retrieve, and I go to the session payment intent for that. And again, I only know that this is how all of this works because I went to the Stripe docs and I looked up how to retrieve a session after the fact if you had a session ID, and then how to retrieve a payment intent from a session. And so with these two things in place inside of my success here, just for debugging purposes, I'm going to debug both of them, which will just dump them to the screen. And then we'll see what they include and how we could use that information to confirm this payment. So, you know, in your project, you probably don't need to have them outputting here. You're just going to look into the payment intent and you're going to check to see if the user payment actually went through at this point. So let's see what this looks like in the application here. I'm going to go back here. I'm going to buy, oh, an awesome paper chair. And Wally Glutton. Okay, that is the, I think this is the session ID right up here. If you look here, I think this is it. The CS test B1BQ. That, I think that's it. I'm going to click pay here. I should be getting redirected back. And look in the URL up here. We now have /checkout/success !_ session ID. And then there's the ID, the CS test with the B1BQ, etc., etc. And then this got pulled in here. We retrieved the session from Stripe, and then we retrieved what's called the payment intent. And that's the crucial thing. And so if we look over here, this is the session. It includes such things as like what was purchased, the awesome paper chair, and the description, the currency, how much we asked for, the amount. Is that the amount? That seems like the wrong amount. This seems like the actual amount. Oh yeah, this is the taxes. Yeah, that's this one here. And then this is the actual amount. If we scroll all the way down though to this is the payment intent. Inside of the payment intent, we have things like billing details. I only offered the credit card, the postal code. You can actually change Stripe to ask for more things. So another way of getting address details from your customer in your project is to not bother implementing getting address details yourself. You can configure the Stripe API so that when you redirect to that payment page, you can have the Stripe API ask for those address details, and then they'll come back to you in the billing, and I think you can actually get a shipping address as well. And then here's some of the crucial information. This pay flag. Did the payment actually work? Was it true or false? So, you know, this is one of the things you would probably want to test inside of your controller here for the payment intent. Was that paid flag true? And then also, how much was actually paid, which is the amount captured here. And really, you would want to check, you know, I don't know if it's the amount or the amount captured. They look the same. You need to look that up in the Stripe API. But nonetheless, you want to look to see if that actually matches what you asked the customer for, right? If you asked the customer for $781 and you got back $781, well, then that's good. Not only did they pay, but they paid you the full amount. If they paid, but for some reason they paid you not the full amount, well, you probably wouldn't want to start sending them off their goods. You'd probably want to contact them and tell them that they didn't pay in full. This was a hilarious bug. I don't even know it was a bug. It was just like a hilarious hack back in the early days of PayPal. In the really early days of PayPal, you could add a buy now button to your website by simply just pasting in some HTML. There wasn't even any JavaScript. It was just an HTML form that you would paste into your page. And in that form was a hidden input for the price of the product. And you could change that as the end user. You could use, like, developer tools didn't really exist at that time, which is probably why they thought they were safe. But you could still use like a tool like Curl, and you could hit the same endpoint and you could just submit a different price. And a lot of websites didn't check. And so you could just say, yeah, I'd like to buy that thing. And you'd send off the request and you just change the amount to zero or to a penny or something like that. And then you could buy things on PayPal for no money. That doesn't work anymore, but that used to work in the real early days of PayPal. So those are some of the things you'd want to check on the payment intent. And so at that point, then you could go and retrieve the actual order that the user ordered. You could probably do that because maybe you saved the session ID in your order. So then you could look up the session ID, match it with the order in your database, and then stamp that as being paid. And there are marks on the project for being able to programmatically switch a order from an unpaid to a paid state in that manner. Again, though, this is a super sketchy way of dealing with the problem. So why, I will ask you, why is this so sketchy? Why would we not want to rely on this redirect back to our success page to confirm that a payment was actually made? Did anyone have any thoughts on this? That's a good one. Some transactions take time. So by trying to immediately confirm the payment, you might see that the session says that the payment did not go through. But sometimes, especially if the sort of the I don't know if it's called the sketchiness rating, but that trustworthy rating of the credit card, sometimes a credit card payment will be put on hold just for a small amount of time. Sometimes they'll actually block it, even though it is a valid purchase. And so you're right. Sometimes so that is one reason why. Wasn't the one I was thinking of, but that is a great reason why you wouldn't want to trust it. And if you had a webhook, well then, you know, when the payment did go through, then you would be told, and that could be, you know, any amount of time after the fact. What's another reason why this might be sketchy? It's definitely a vector for something, right? Because like we now have an endpoint where you can put a session ID into that endpoint and inject that into our system, right? So it might not necessarily be cross-site scripting, but it does give bad actors a potential place to like give us weird session IDs and have us trying to retrieve those from Stripe. So maybe somebody finds a session ID, maybe through like Wi-Fi sniffing of a payment that was successful, and then they send that to your endpoint and they try to use that to mark a particular session as paid. There's problems there as well. Anyone else have any beyond those two? Because those are two really good examples of why. So you're seeing like the list is building. This is bad for many reasons. Okay, I will say my final bit of sketchiness. This is wrong for so many reasons, but another reason why this is wrong is the internet is unreliable. And so, if the user is making this transaction, say on their mobile phone, and they're on like a really bad like 3G or connection, or they go through a tunnel, and in the process of the payment is successful, but they in the process of being redirected back to your website, they lose their network connection, their internet connection goes down, then they never get back to the success page, and then your website just never thinks that the payment went through. And so you shouldn't be relying on the end user's internet connection as being the way that you find out that a payment went through. So that is the final reason for the sketchiness. So like the three that seem to stand out there is that not all payments go through immediately, that this is a potential vector for attack because we're allowing outside data into our Stripe session retrievals, and then just the unreliable nature of the internet means that not everyone is going to be properly redirected back to this success endpoint. And so for all of those reasons, if you were implementing this in a real world application, you would really want to use webhooks. So for your project, to simplify things, go ahead and use this brittle process. If you really want to play around with webhooks, you can go that route. But in the end, in terms of like marks for the product, you're going to get the same marks either way.